Continuing on with Unit 2, and in this video we're going to talk about learning target 4D, which is all about solving quadratic equations by completing the square. By the end of this lesson, you will be able to solve a quadratic equation by completing the square, as well as use completing the square to convert a quadratic function from standard form to vertex form and then find the vertex. So in our last learning target, we learned how to solve quadratic equations by given a graph, by using square roots, and by using the zero product property. What we talked about a lot in those videos was that those only work in certain cases. Now if I have a graph, then I can definitely find the x-intercepts, which are our solutions from that graph. When I solve using square roots, so that only works if b is equal to 0. And for the zero product property, it requires that the quadratic equation can be factored, which is not true for every quadratic equation. So now we're going to start talking about ways that will work for any quadratic equation. And so our next method of completing the square technically works in all cases, but is easiest when b is an even number. And the reason we're going to want b to be an even number is because we're going to end up dividing by 2. And although it will work if b is an odd number, if we want to avoid messy fractions, that's why we would want b to be an even number. But technically, completing the square does work in all cases. So let's talk about what completing the square is. So we can form a perfect square from any x squared plus bx by adding a new c term, and this new c term is going to be b over 2 squared, where b is coming from that coefficient on our x term, and then we'll half it, and then we'll square that number. The reason this works out as a perfect square is we can always factor x squared plus bx plus b over 2 squared as x plus b over 2, the entire thing squared. And I want us to look at an x games to see why that works out. So in this case, if I was trying to factor the left side here, I would be looking for two numbers that multiply to be b over 2 squared and add to be b. And the two numbers that works on is b over 2 and b over 2. Since b over 2 times b over 2 would give me b over 2 squared, and b over 2 plus b over 2 would give me b. And since I have the same numbers here, I could rewrite this factored form as x plus b over 2, the entire thing squared, thus creating this perfect square. This process is called completing the square. Before we jump into some examples where we actually solve for x, I want us to just practice finding this new c term and using that to complete the square. So our new c term again is this b over 2 squared. Let's look at example 1. We have x squared minus 10x, and we want to compute b over 2 squared for this quadratic that we have. So in this case, our b value is negative 10. So we're computing negative 10 over 2 squared, which if we simplify the inside first, inside the parentheses, negative 10 over 2 is negative 5, and then negative 5 squared is going to be equal to positive 25. This right here is that new c term. What we can do then is we can add 25 to this quadratic. So instead of just having x squared minus 10x, we now have x squared minus 10x plus 25, which enables us to factor this. And so we're looking for two numbers that multiply to be 25, but add up to be negative 10. That would be negative 5 and negative 5, which is why we can rewrite this as x minus 5, the entire thing squared. Something else that I want to point out here is that in our completing the square formula, when we go to factored form, we're always getting this b over 2 squared, which is coming from that new c term that we're computing. So when I simplified down this negative 10 over 2, I got negative 5, which is exactly what I have inside my factor. And that's always going to work out because of the completing the square process. Let's look at example 2. We have x squared plus 6x, and we want to find our new c term. So we are after computing this b over 2 squared. Why don't you guys pause the video, identify what your b is, and then simplify down what b over 2 squared would be equal to. So for this example, our b is 6, so we have 6 over 2. We are squaring that, so we end up with 3 squared, and then 3 squared gives us 9. Now that we know what our new c term is, I can go ahead and add that to our original quadratic. So we get x squared plus 6x plus 9. why don't you guys pause the video and factor this into its perfect square? So when we're factoring this quadratic, we're looking for two numbers that multiply to be 9 and add up to be 6. That would be positive 3 and positive 3, which we could write as x plus 3 squared. So in this completing the square process, we're taking stuff that could not be factored into a perfect square and adding this new c term so that we can create a perfect square. Now let's talk about how this is going to work if we're actually trying to solve a quadratic equation for our x value. So how to solve a quadratic equation by completing the square. A little overview at the top, because we do have some extra things in the problem that are not really necessary, but I kind of want to move out of the way. So when I look at this first example here, I don't just have two terms. I don't just have this x squared minus the 14x. I also have my old constant term. So the first thing we want to go ahead and do is move that constant term to the other side. Because right now, if we were to try to factor this, we would not be able to find any factors that would work. So our goal in completing the square then is to move that constant term that's not working and create a new constant term that would work. So our first step here, we're going to subtract that 16x to the other side. My next thing that I want to do is I want to compute this b over 2 squared, and I want to add it to both sides. So in this example, our b is negative 14. So I'm going to add negative 14 over 2 squared to both sides. And this is key. I can't just add it to the left side and try to keep solving, because then I would have changed the problem. So to balance that out, I need to add it to both sides so that my equation stays unchanged and it's still equivalent to the original equation that we started with. So this is so key that we have to add it to both sides. And we can see down below where I have this negative 14 over 2 squared on the left and that negative 14 over 2 squared on the right. And this is keeping that equation balanced. Now that we've added our b over 2 squared to both sides, I want to simplify both of these right now, and then I'm going to keep going on with the next steps. So let's simplify what b over 2 squared is. So negative 14 over 2 would be equal to negative 7, and then negative 7 squared would give us a positive 49. So what we really have is a plus 49 on each side. Our next steps from here is we should factor the left side. Remember, this should always be able to be factored if we've added the correct b over 2 squared term. So we're looking for two numbers that multiply to be 49 and add up to be negative 14. That would be negative 7 and negative 7, so we get x minus 7 squared. And remember, a shortcut way to get that number is you can simplify down that b over 2, and negative 14 over 2 is that negative 7. So we factored the left side. Now on the right side, we just want to go ahead and simplify. Negative 16 plus 49 gives us 33. And now from here, my goal is to solve this for x. By creating this perfect square on the left-hand side, I can actually incorporate something that we've learned in a prior video, which is solving using square roots. We learned in our last section that once I get an x squared isolated, I could square root both sides. Now here I don't just have an x squared, I have an x minus 7, the entire quantity squared, but I can go ahead and apply a square root to both sides of this equation. And again, I want to not forget that plus or minus on the side with the constant term. The reason this is helpful is the square root of something squared is just that something. So on the left side here, the square and the square root cancel, and we just get x minus 7 equals, on the right side I have that plus or minus the square root of 33. If we could simplify the square root down, we would want to. 33 is not a perfect square, and it doesn't have any perfect square factors inside of it, since 33 factors is 3 times 11. So I can't simplify this any further, but if we could, we would want to continue to simplify. My last step here that I want to do is I want to solve for x, since my goal was to solve this quadratic equation. To get x by itself, I'm going to add 7 to the other side, and I'll end up with x equals positive 7 plus or minus the square root of 33. And that will be our final answer. And I do want to remind you guys that this is representing two answers. It's the 7 plus the square root of 33, as well as the 7 minus the square root of 33. And if you prefer to write it out as two separate answers, that works as well. Or if you want to kind of shortcut it and write it with the plus or minus, that is acceptable as well. So in this completing the square process, we're using a lot of skills from our prior sections. We're having to factor, we're having to apply square roots. The new thing that we're computing is this b over 2 squared. And that allows us to then have this perfect square on the left-hand side, which we can then factor into a perfect square, which then allows us to apply the square root to both sides and then isolate the x from there. One key thing I do want to keep reminding you guys is don't forget that plus or minus when you're applying the square root to the constant term side. That way we end up with both of our answers. Okay. Let's look at example 4. So in example 4, we have x squared plus 8x minus 15 equals 0. Now, if we were to try to factor it, we wouldn't be able to factor this as it stands. There are not two numbers that multiply to be negative 15 and add up to be positive 8 in this case. So I cannot factor this. I cannot use square roots right off the bat since I do have a middle term here of 8x. And although we could try to graph it, that would take a lot of work to figure out what all the transformations were. Since this is not in Vertex form right now, this is actually in standard form. So what we're going to do instead is we're going to complete the square. So our first step that we want to do, move that constant term to the other side. So we have x squared plus 8x equals positive 15. So I'm moving that old c term to the other side since it's not helpful in factoring. Our next step is that we want to compute this b over 2 squared term and add it to both sides. So why don't you guys pause the video right now, compute what b over 2 squared is equal to, then add it to both sides of your equation. So in this case, our b value is 8, so we have 8 over 2 squared that we're going to add to both sides. So we get x squared plus 8x plus this 8 over 2 squared equals 15 plus 8 over 2 squared. And I want to make sure that I'm adding this b over 2 squared term to both sides because I need to keep my original problem balanced. And it wouldn't be fair to just add it to one side without adding it to the other side. That would actually be changing the problem. Now that we've added b over 2 squared to both sides, let's go ahead and just simplify down what that is equal to. So 8 over 2 is equal to 4. 4 squared is equal to 16. So we're adding 16 to both sides. Now from here, we should be able to factor the left-hand side and simplify the right-hand side. Why don't you guys pause the video and factor the left-hand side right now and simplify the right-hand side. So to factor the left-hand side, we're looking for two numbers that multiply to be 16 and add up to be positive 8. That would be positive 4 and positive 4, so we end up with x plus 4 squared, which we know has to happen since this is going to create a perfect square. I will always get that same number twice. On the right-hand side, 15 plus 16 would give us 31. Now that we've factored the left-hand side and we've simplified the right-hand side, our goal is to continue solving for x. So we want to apply a square root to each side and then isolate that x value. Why don't you guys pause the video and finish solving off example 4 on your own. So our next step in solving this, guys, I'm going to apply the square root to both sides. I want to remember that plus or minus on the side with the constant term. Now the square root of x plus 4 squared will cancel those two out and I'll just get left with x plus 4. Then on the right side I get equals plus or minus the square root of 31. Again, the square root of 31 cannot be simplified anymore, but if it could, we would want to. Our last step here is to get x by itself, so I want to subtract 4. So we're going to get negative 4 plus or minus the square root of 31. And that will be our final answer. And I want to remind us that we do have two answers there. We have negative 4 plus the square root and negative 4 minus the square root. You might be wondering why I'm always putting the integer value before the square root. The reason being is if I put the number after the square root, although that is okay, I want to make it very clear which number is inside my square root and which number is not inside my square root. So to avoid having to worry about that too much, if I put the integer term before the plus or minus, then it's clear that only the 31 is inside that square root. So we've looked at two examples how we can solve quadratic equations by completing the square. So in both examples 3 and 4, our goal was to actually solve for x here. And we did that by moving the old constant term to the other side, adding this b over 2 squared term to both sides, simplifying down, then factoring the left-hand side, simplifying the right-hand side, applying a square root to each side, remembering that plus or minus on the constant term, and then getting x by itself by adding or subtracting whatever number we had over to the other side. Now in this last part of this video, we're going to still use the concept of completing the square, but instead of solving, we're going to talk about how I can rewrite a quadratic function from standard form into vertex form. So we talked about standard and vertex form back in Learning Target 4a. Standard form of a quadratic function, remember, is the a times x squared plus bx plus c. And this was not helpful when we were graphing. We could not see the transformations in it, and because of that, it makes this a little bit difficult if we were to try to graph it. Vertex form, on the other hand, was a times x minus h squared plus k, and our vertex is that h comma k. Vertex form is really helpful when we're graphing because we can identify all of our transformations in it and then apply those transformations to our start points from there. What completing the square not only allows us to solve quadratic equations, it also allows us to convert from standard form to vertex form if we were to complete the square. So I'm using CTS to stand for completing the square here, and I can use that to go from standard to vertex form. Now let's look at our first example, and we're going to see a lot of similarities between examples 3 and 4, and we're going to see how at some point, instead of going to solve for x, we're going to instead re-isolate the y term. So our goal here in example 5 says to rewrite y equals x squared plus 4x minus 6 in vertex form by completing the square, and then we want to find the vertex. So let's write out our original problem here. We have y equals x squared plus 4x minus 6. So right now we are in standard form. To get that in vertex form, I would want that number times x minus h squared plus the k. So ultimately, by completing the square, I'm able to figure out what this x minus h squared is. We're going to do the same couple first steps that we did before. I want to move my constant term to the other side. So this negative 6 is not helping me being able to factor, so I'm going to move that negative 6 to the other side, and I'll get y plus 6, and then equals the x squared plus 4x. Now you'll notice I left a big space after the plus 6 before the equal sign, and I did that deliberately on purpose. The reason I did was our next step was we wanted to add that b over 2 squared term to each side. So in example 5, what would our b over 2 squared term be equal to once we simplify it down all the way? So in this case, our b term is 4, so I'm taking 4 over 2 and I'm squaring it. So I'm going to be adding that 4 over 2 squared to both sides of this equation, just like we did before. And this is fair game because as long as I do it to one side and I do it to the other, I'm keeping my equation balanced. Now we do want to simplify this down. 4 over 2 is equal to 2, and then 2 squared is giving us back that 4. So what we really have is y plus 6 plus 4 equals x squared plus 4x plus 4. So we moved our old constant term to the other side, just like we did before. We've added our b over 2 squared to both sides, and I've simplified down. You will notice that the sides are honestly flip-flopped before. We had the x squared on the left, and we had the constant term on the right. But that's okay that they flip-flopped. Now what we want to do is we want to factor our right-hand side, and I want to just simplify down my left-hand side as much as I can. So why don't you guys pause the video right now and simplify down the left-hand side and then factor the right-hand side. So on the left side, I can add the 6 and the 4 and get y plus 10. And on the, that was on the left side. On the right side, when I factor this, I'm looking for two numbers that multiply to be 4, add up to be positive 4. That would be positive 2 and positive 2. So I end up with x plus 2 squared then. And of course, if you want to be doing an x games on the side to kind of organize your thought process, two numbers that multiply to be 4, add to be 4 would be that 2 times 2. Now from here, things are going to get a little different than they were before. So before in the prior two examples, since we were solving for x, our goal was to isolate that x. Well, now I'm trying to get my equation into vertex form. And in vertex form, it's not the x that is isolated, it's actually the y term that's isolated. So although we have it as an f of x up here, f of x and y are the same thing. So if I'm trying to get this into vertex form, my goal is to isolate the y. All the prior steps were the same, it's just from here that it's going to change a little bit. So now that we've simplified the left-hand side, factored the right-hand side, instead of applying a square root, we just want to get y by itself. So I'm going to subtract 10 over, and I'll get x plus 2 squared minus the 10. And this is our vertex form that we were after. And now that we have it in vertex form, we can actually identify what the vertex is using those transformations and remembering that for any quadratic in vertex form, that vertex is always h comma k. So why don't you guys pause the video and identify the vertex for example 5. So in example 5, our vertex is going to be a -2, comma a -10. And where that's coming from is our h value here is actually -2. Since I have x plus 2, that's a transformation to the left. So that's why I have -2 in my vertex, since I went to the left. And then the -10 is my k value, and that's also telling me that I'm going down 10, so that's why my y value is going to be a -10, to match up with the transformations of going left 2 and then down 10. So in example 5, we are able to see how this is really similar to what we did up above when we were solving. The big change occurs once I factor each side and simplify that instead of applying a square root now, I just want to move that constant term to the other side to get y by itself. Let's look at one last example. So in example 6, we have y equals x squared minus 6x plus 11, and we want to rewrite this in vertex form by completing the square, and then we want to find the vertex. So I'm going to go ahead and rewrite out our original problem. So we have x squared minus 6x plus 11. What would be our first step here to getting this into vertex form? So our first step in completing the square is we want to move that old constant term to the other side. So I'm going to go ahead and subtract over that 11 to the other side. So I have y minus 11 equals x squared minus 6x. What would our next step be? What are we after next when we complete the square? So our next step from here is we want to compute this b over 2 squared. Why don't you guys pause the video and determine what b over 2 squared would be equal to. So in this case, our b is -6, so we get -6 over 2 squared. If we simplify this down, we'd get -3 squared, which would be giving us +9. So we're going to add this b over 2 squared term, which is equal to +9, to both sides. I'm going to show the step of just adding the unsimplified term so that we can see it. And remember, we have to add it to both sides to keep the equation balanced. And then if we were to simplify that down, we would be really adding 9 to each of these sides of the equation. Now from here, what would we need to do next in order to be able to get this into vertex form? So our next steps from here is we want to simplify the left-hand side, and then we want to factor the right-hand side. Why don't you guys pause the video and do those two steps right now. So on the left-hand side, when we simplify, a -11 plus 9 is giving us a -2, so we have y minus 2 equals, on the right-hand side when we go to factor this, we're looking for two numbers that multiply to be 9 and add up to be -6. That would be -3 and -3. So we end up with x minus 3 squared then. Now from here, to get it into vertex form, what is the last thing that I need to do? So my last step here is I want to isolate that y so that I'm in vertex form. So I'm going to add the 2 to the other side, and we get x minus 3 squared plus 2. And this right here will be our final answer in vertex form. Oops. There we go, form. The last thing the problem did ask us to do was find the vertex. So why don't you guys pause the video right now and determine what the vertex would be for this quadratic equation. So for this quadratic equation, we have a transformation of going right 3. So our vertex will be positive 3, comma, we also have that transformation of going up 2. So we get positive 3, comma, positive 2 as our vertex then. So in this video, we learned what the completing the square process is and how we compute this new b over 2 squared as our new constant. We want to make sure that we're always adding that to both sides, whether this is in solving using completing the square or if we're rewriting it. We definitely have to keep our original equations balanced and add it to both sides. And then we have the option from here to either solve, like we did in examples 3 and 4, where we added it to both sides, simplified it down, factored the left, simplified the right, and then to solve for x, we had to apply a square root to both sides. Of course, we don't want to forget that plus or minus, and then isolate the x by moving that constant term over. Versus in examples 5 and 6, when we're rewriting it into vertex form, after we add our b over 2 squared to both sides, we still simplify and factor, but instead of applying a square root here, we just want to move that constant term to the other side to get y by itself, and that allows us to be in vertex form. And not only from here can we determine what the vertex is, but now that we're in vertex form, we could list our transformations, we could have the start points, apply the transformations to the start points, figure out what points we'd want to graph, and then from there find the domain, the range, and the axis of symmetry for this graph, as well as determine if the vertex would be a maximum or a minimum. So completing the square is an excellent tool not only for solving, but also from converting from standard to vertex form so that we can do so much else and rely on everything we learned back in Learning Target 4A with graphing, which forced us to be in vertex form. And sometimes there's problems that are given in standard form, and so by completing the square and moving into vertex form, we're then able to do all that stuff that we learned back in Learning Target 4A.